This video is about simplifying expressions with square root. The square root here is represented by the radical. So this is called, the symbol is called the radical. The number inside the radical is called the radicand. Okay, so in order to group expressions with radicals, they have to have the same radicand. For example, the square root of 3 plus 4 square root of 3, I can group it because this is the same. And when it's the same, I can factor it. The 1 comes from here. The 4 comes from here, and that gives me 5 square root of 3. So here we have square root of 8, here we've got square root of 2. 2 is the smallest of the two. So let's try to change 8 into something else. Now we also need to know that the square root of x squared, a perfect square, is equal to x. So let's now write 8 as a factor of prime numbers. Now, prime numbers, let's review them. It's the 2, the 3, the 5, the 7, and so on. So these are prime numbers. So 8 is equal to what? 2 times 4. 4 equal to what? 2 times 2. So I have used the 2 only. And this gives me a perfect square multiplied by 2. So what I'm going to do, substitute my 8, this 8, by this expression. So let's go to A, expression in A. Square root of 8 is 2 power 2 multiplied by 2 minus 4 square root of 2. Now remember what we said here. Now hang on, before we use this, let's use something else. We need to use now the fact that the square root of A multiplied by B, I can split it. So let's go here, split this. Good. Now this is the square root of perfect square. So square root of x2 gives me x. So this gives me 2. 2 times 2 times square root of 2 minus 4 square root of 2. 2 by 2, 4. Minus 4 square root 2. And all this gives me my 0 here. Now let's go to question in part B, which is the 2 plus square root of 12 over 2. Now, when we look at it as it is, there isn't much to simplify, unless we change the square root of 12. Okay, so the 12, let's write it again, as I said before. Let's write it as a product of prime numbers. You remember prime numbers, 2, 3, 5, 7, 11, and so on. These are numbers that have only 1 and itself as a factor. So I start with always with smallest one. 12 is equal to 2 times 6. Now I look at 6. 6 is what? 2 times 3. And then I cannot do any more because the 3 cannot be factored. So this gives me a perfect square multiplied by 3. Now let's go back to our expression, see what we can do. So this is equal to 2. 12. 12 we replace it by, we substitute it by 2 power 2 times 3 over 2. Now here what do we have? We have the form square root of AB, which we can split as we said before. So that gives me 2 plus square root of 2 square, the 2 power 2 square root of 3, 2 here, equal. Now the square root of perfect square. Okay, now we factor these two here. It's a common factor, so we take it outside. 1 plus square root of 3, and then we divide by 2. This 2 comes from the thing. Now here it's easy now, because there is 2 multiply something and 2 multiply 1. We can divide by 2, and this becomes in the simplified form 1 plus square root of 3. Now let's go to the question in part C, where we have the radical here, square root of 3 here, and the square root of 3 in the denominator. And there is no way we can simplify this unless we make some changes. Now let's look at 6 over square root of 3. If we multiply numerator and denominator by square root of 3, there is a possibility to simplify. So the numerator becomes 6 times square root of 3, and here we have square root of 3 times 3. Now what we did here, we used this rule, A, B. We used this rule in reverse from here to here. So instead of splitting, we grouped. And this is, now this can be simplified. Now let's go here. And this can be simplified as 6 square root of 3. Now 3 times 3, it's 3 power 2, which is a perfect square. And that gives me 3. So let's go back to our expression and substitute. So 6 square root of 3, which is here, it gave me this, and then simplified to this here. 6 square root of 3 over 3. And that gives me 2 square root of 3. 6 divided by 3 gives me 2. And here I can group because it's the same radicand and the same radical. So 4 square root of 3. Now let's go to part D. Before we solve it, let's review certain things. First, if I have the square root of x and then I square it, that will give me square root of x multiplied by square root of x. That will give me the square root of x2, and that will give me x. The second thing, if I have a minus b multiplied by a plus b, that will give me a multiplied by a, that's an a square, and then ab, and then minus ba, and then minus b square. I will put the minus b square here. Why? Because plus ab minus b, now ba and ab is the same thing. The multiplication is commutative. So plus ab minus ab, all this becomes 0. And that's what we need to retain, that a minus b multiplied by a plus b equal a squared minus b squared. Now suppose we have square root of a, square root of b, square root of a, and hang on, let's put it separately. So suppose I have square root of a minus square root of b multiply square root of a plus square root of b. And if I apply this, what do I say? I say square root of a power 2 minus square root of b power 2, and then we have seen above here that square root of x power 2 gives you x. So that gives me a minus b. And this idea has simplified, has eliminated the radicals altogether. Now, this and these terms are conjugate of each other. So for example, this is the conjugate of this expression. How do you make the conjugate? It's very simple. you change the sign. Here it's a minus, it becomes a plus. If it's a plus, it becomes a minus. Okay, now let's go back to our expression and start dealing with the term with the fraction. So it's 1 here. Now we have a square root of 5 minus 2, square root of 5 here. And then we are going to multiply it by the conjugate. We said the conjugate is you change this minus into a plus. But remember, you need also to multiply the numerator by the same expression, so that this with this gives you 1. Remember, the same quantity divided by itself gives you 1. So we did not change anything to our expression, the square root of 5. Now 1 multiplied distribution, of course, here. And now here we are going to use what we said here. So square root of 5 power 2 minus 2 power 2. So is equal to 3 square root of 5 minus square root of 5 plus 2 here, and then at the bottom, at the denominator, we're going to have square root of 5 power 2, that gives me 5, and then minus 4, and all this is equal to 1. So 3 square root of 5 minus square root of 5 minus 2. Remember, you distribute the minus, and that gives me 2 square root of 5. Can you see this and this, the same radical, the same radical? There is a 1 here. So we do 3 minus 1 gives me 2. Square root of 5 is the common term. And this is the answer. This is the expression given to us in part D in simplified form.